What's going on, my friends? You should be watching this on Friday, May 1st. I am recording this on Thursday, April 30th. As you can see, Thursday, April 30th. We are on lesson 13. The title of our lesson is Decimal plus Decimal. We started to talk about this on Wednesday, and we introduced it by adding our fractions together and then looking at it like adding two decimal numbers together. Now remember, in order to be on lesson 13, you must have finished 1 through 12. I was feeling generous, so I cut out 11. So don't worry about 11. We're going right to 13. So make sure you're done lesson 12, and we'll be on lesson 13. You might want to go back and watch those videos if you need a little refresher. Remember, you guys are in charge of your fluency activities, your number gym, and your pair compare. If you're having trouble, just reach out to me, give me a call. You can shoot me a message on Google Classroom. I'm always available. Get in touch, and I will help you out. Let's go ahead and read our objective. Students will be able to add decimal numbers by converting to fraction form. So that'll be our Zearn lesson. What I'm going to show you before that is how to add decimal numbers without converting to fractions. I want you to be able to do it both ways, but I think just adding your decimals without fractions, without converting it to fractions, is a really, really helpful skill that'll help you do this math much faster. So let's start off with that. This will be a little bit different. What I want everybody to do is have a piece of paper or a notebook out, something that you can write on. We're going to be solving problems. All right, my friends, before we solve any problems, let's take a look at a little review here. We're going to rename our decimals. If I have 28 tenths, that's like saying 2.8. 2 and 8 tenths. How many ones do I have? It looks like I have 2. How many tenths do I have? It looks like I have 8. Make sure your places are organized. All right, for our second problem, 73 hundredths. If I have 73 hundredths, that's like saying 0.73. All right, hundredths, our second decimal place, but I can't have 2 digits there. So I have to move my 7 to 7 tenths. So that's 7 tenths and 3 hundredths. Notice how I split them up by their places. And this is going to come in handy when we're adding our decimals together. Let's take a look. All right, my friends. So one way to add decimals together is to use the standard algorithm. Our question, add 7 tenths and 6 tenths. We need to add them together. 7 tenths plus 6 tenths. Step 1, line your decimals up in the standard algorithm. That is our vertical algorithm. We're going to make sure that we line these up so the places are stacked on top of each other. So we want to have our first number. We have our ones place and our tenths place, 0.7. And then under that, we want to make sure it's nice and organized. So our ones place here, 0.6. 7 tenths plus 6 tenths. Here's my standard algorithm. It is perfectly lined up. And I know it's lined up because my decimals are in line. Notice they're in a perfect line. All right. Now let's go ahead and add these. When we add these up, we add like our standard algorithm, our normal algorithm with whole numbers. So start with your smallest place value, our tenths place. Everyone, 7 plus 6 is what? Nice work, 13. Drop our 3. We carry our 1 to the next place. 0 plus 0 is 0, but we have 1. Now let's think about this. If I have 2 decimals being added together, 7 tenths and 6 tenths, can my answer be 13 wholes? It can't. It can't be 13, right? It's way too big. It is not reasonable. So what you want to do is you want to bring your decimal directly down. Notice my decimal stayed in line the entire time. All right. And my answer is 1.3 or 1 3/10. And that's your final answer. You create a standard algorithm, you make sure your places are lined up, and then you add them together like normal, and just make sure your decimal falls right in line with the decimals in your problem. Let's look at another example. Okay. Here we have 200ths and 900ths. 200ths and 900ths. I'm actually going to come right over here to our place value chart. And I'm going to show you what it looks like, my standard algorithm in a place value chart, so you can get a good look at it. So we have, all right, 0, 200ths plus 900ths. All right. Your first step, step 1, create a standard algorithm. We're going to do it within our place value chart. So let's do our first number, 0.02. That's 200ths plus 0.09. Notice my hundredths are lined up, my tenths are lined up, and my ones are lined up. We're ready to add. Let's do it. 9 plus 2 is what? 11. Nice job. Drop your 1, carry 1 to the next place. 0 plus 0 is 0, but we have 1 here, so we have to add that in. That's 1. And 0 plus 0 is 0. Now we know our answer can't be 11. That's way too big. We had decimals here. So this decimal, you have to drop that down to your answer. When we're adding or subtracting decimals, that stays in line. Our final answer is 0.11, or 0 and 11 hundredths. 0 and 11 hundredths is our final answer. Okay? Now, let's take a look at a common mistake that happens. It happens all the time, especially when you're first learning how to do this. Let's come down to this problem here. Okay, I want you to read it on your own while I read it aloud. What did Mr. Prada do wrong? Here we go. What did Mr. Prada do wrong in the problem below? So we're adding 23 and 9/10 plus 4/10. What did I do wrong here? Okay, it looks like I lined it up, but I did something wrong. I want you to pause the video, examine this problem, and tell me in Google Classroom, what did I do wrong? All right, I just read a bunch of your answers. I hope you paused the video. Hold on, you know what? Let me pause it right now. Okay, I'm back. So I read the answers. Some of you were on track. Good work. Some of us made very common mistakes. You see them all the time when you first start adding and subtracting decimals. I'm going to tell you, I can see my decimals are not lined up. Notice I have 1 here and 1 here. They are in different spots. That means my place values aren't lined up. I am not allowed to add these together as is, okay? Let's fix this problem. 23 and 9/10 plus 4/10. I'm going to use my place value chart. I think it's a really excellent tool for making sure that everything is nice and organized by place value. So we had 23.9 plus 0.04, I believe. Okay, let's plug it in. I have 2 10s. I have 3 1s. I have my decimal point, and I have 9/10. Here I have no 10s, no 10s at all. I have 0 1s. I have 0 10ths, and I have 4 hundredths. Notice I had to shift my digits back to make sure they were in the correct place. Now, what you can do, you're allowed to add them together like this, but if you have any open spaces in front in your larger place value, so our 10s in this case, I could fill it with a 0. just as a placeholder. And over here, my hundredths, right? I only have 9/10, but I could put a 0 here to help me do my addition. And now our numbers are nice and lined up, and we can go ahead and add. Step 2. We're going to add them just like we normally do in our standard algorithm. Start with your smallest place value, your hundredths. 0 plus 4 is what? 4. Nice job. 9 plus 0 is what? 9. Good work. Let's come over here. 3 plus 0 is what? 3. Very nice job. And 2 plus 0 is what? 2. Very good. Okay, I know that 23.9 plus 0.04 can't be 2,394. That's way, way, way too big. Our numbers are much smaller here. We need a reasonable answer. But we know that our answer when we're adding or subtracting must have a decimal in the exact same place as it was in the problem. We just drop it right down in the answer. And our final answer is 23.94, or like we say in a math class, 23 and 94 hundredths. Nice work, my friends. Good job. All right. Let's do 2 more problems. What I want you to do, I want you to do these 2 problems on your scrap paper, and then I want you to go to Google Classroom, and in a private message, I want you to write your answers to see if you're correct, okay? So this says choose 3 to solve on your whiteboard. We're not going to choose 3 because we only have 2 listed here. So I want you guys to do 3 and 5/10 plus 6 and 2/10. And then I also want you to do 2 and 6/10 plus 7 ones. All right? Remember to line up your place values before you add. Make sure you're adding your hundredths, your tenths, your ones, and your tens if there are any. I don't think there are any here. Okay, pause the video now, and I will see you in a second. All right, my friends, you are back. I got some really good answers. I'm going to show you guys how to do these problems. Let's start by plugging in our numbers here, 3.5 and 6.2. We're going to go to our place value chart. All right, let's write our addition sentence at the top, 3 and 5/10 plus 6 and 2/10. All right, we have 2 terms there, 2 values. Let's plug them in. We'll start with 3 and 5/10. That's 3 ones and 5/10. And then we have 6 and 2/10 here. Let's plug that in underneath, 6 and 2/10. Everything's lined up. Our ones are lined up. Our tenths are lined up. Let's add. 5 plus 2 is 7. Let's go to our ones place. 3 plus 6 is 9. Our answer can't be 97. It's way, way, way too large. It's not reasonable. To make it reasonable, we have to drop down that decimal, keep it in line. Our final answer, 9 and 7/10. 9.7. Very nice job. All right, let's check our next problem. 2.6 plus 7. Always start with your addition sentence, 2 and 6/10 plus 7 wholes, all right, or 7 ones. So let's write this first number in, 2 and 6/10. Our second number is 7. Let's write it in. What did I do wrong here? What did I do wrong? If you're screaming at your laptop, Mr. Prada, you wrote your 7 ones as 7/10. You're correct. This is not the right place to put that 7. Those are 7 ones, so I need to put 7 into our ones place. Okay, this looks good. We could add it, but what I like to do and what I want you guys to practice is filling in any open spaces that are decimals with zeros, all right? That'll allow you to keep everything organized and give you another digit there to use when you're doing your standard algorithm. Let's add. Start with your smallest place value, your tenths. 6 plus 0 is 6. Let's go to our ones next. 2 plus 7 is 9. Our answer is 9.96. No, it's not. Good job. 96 is way too large. Our numbers are much smaller here. We only had ones, right? We can't have a 10. We can't have 9 tens when we only have 2 ones and 7 ones. So keep your decimals organized. Let's put that down here. Our final answer is 9 and 6/10. Nice work, my friends. Okay, keep this in mind. We're going to go over this again during your Zearn lesson, which we're going to bounce over to now. The reason why I wanted to show you this first is because they go really deep with fractions, but I want to make sure you have this method because this method is really, really simple, I think, once you start to practice, and it's what you're going to use as you move forward, and you need to add your decimal numbers. All right, y'all, let's do it. Math chat.
Nice to see you again, Math Star. Let's Zearn.
All right, let's start it out with a little warm-up question. Write this expression in unit form. Unit form is where we have our digits, and then we have to actually write out with words the place that it's in. So this 3, it's in our first decimal place. We know our first decimal place is our 10th place. Let's drag and drop that next to 3. Good work. Plus 17 what? Is this a whole number or is this a decimal? Well, it looks like that 7 occupies the second decimal place, so this is our hundredths place, 17 hundredths. Very nice. Let's see if it's correct. Good work. Okay, what they did was they changed, if you notice, they changed their decimals into fractions. Same value, 3/10 and 17 hundredths, but now they want us to add it together as fractions. So let's go ahead and change our 3/10. We're going to have to change that into hundredths. I know I can do that by just adding a 0 here and a 0 here in my numerator. I multiply the top and the bottom, the numerator and denominator by 10. That gives me 30 hundredths. All right. Start to think about this because when you add this together, you're going to get your final answer or your sum. All right, here we're going to add these together, 30 hundredths plus 17 hundredths. That gives us 47 hundredths. Great job. Okay, how do I write 47 hundredths in decimal form? Remember, hundredths is your second decimal place. So no whole numbers, 0.47. Very good. Put that 4 into the 10th place. All right. I'm going to show you how to do this, but using our previous model, our standard algorithm. This is going to help you on your exit ticket. So 0.3 plus 0 ones, 1/10, and 7 hundredths. Notice my standard algorithm here. I have an empty hundredths place up top, and that value, I'm going to fill it with a 0. I'll do it in a different color just so you can see that that's our placeholder. And now we can add these together. Let's do our hundredths place. 0 plus 7 is what? 7. Nice job. 3 plus 1 is what? 4. Very good. And our ones place, 0 plus 0 is 0. I know my answer can't be 47 wholes. It can't just be 47 because we only have decimal numbers here. So I need to make sure that that decimal stays lined up and falls right into my answer. 47 hundredths. Check it out. It matches what we have over here. Good work. Nice job, my friends.
Sophie, take it away.
3/10 plus 17 hundredths looks like this in fraction form. 3/10 equals 30 hundredths, and 30 hundredths plus 17 hundredths equals 47 hundredths.
Rocked it.
All right. So now, before we do this in fraction form, we're going to do it in decimal form. So I really want you to follow what I'm doing right now, my friends. All right. Let's turn our decimals, our addition sentence, into the standard algorithm. So let's do our top number, 0.5. That's 5/10. And here I have 64 hundredths. So a 0 in the ones, 6 in the tenths place, and a 4 in my hundredths place. And let's add it together. Remember, I can have a placeholder right here, 0, that helps me add. All right, y'all, let's do it. Let's start with our hundredths. 0 plus 4 is what? If you said 4, you were correct. 5 plus 6 is what? If you said 11, that's correct. Remember, carry that tens place, that larger digit. And then 1 plus 0 is 1. My answer is 114, but I know that that's not reasonable. I need to make sure that I include my decimal in the answer. So our answer for this problem should be 1 14 hundredths. I want everybody to write that down on a piece of paper. We're going to check back and see if we were correct from the beginning. I'm writing it down right now. 1 14 hundredths. Check it out. 1 14 hundredths. Boom. Let's see if we're correct. All right, we're going to do it their way for a little bit. So let's start by converting each of these into fraction form. So 5/10, here's 5/10, and 64 hundredths, 64 hundredths. And we have a new addition sentence, but it's in fraction form. Nice job. Okay, so I know I can't use this 5/10 and add it to my hundredths. Our denominators are uncommon. These are unlike fractions. So what can I change 5/10 into? If you said 50 hundredths, you were correct. Now we have common denominators. I did so by multiplying the numerator by 10 and the denominator by 10. That's how I keep an equivalent fraction. And that gave me 50 hundredths. And now we can add. Okay, let's decompose 64 hundredths to make 1 with 50 hundredths. How many hundredths are in one whole? So we're going to get a little experimental here. I think that's totally fine. So when I look at this problem, I want to see, can I pull one whole out of these two numbers together? Well, I think I can, because one whole would equal what out of 100? I want you to go to Google Classroom and tell me 1 equals what fraction? What over 100? Pause the video now. All right, you are back. If you said 100 over 100, I think you are correct. Remember, if the numerator and denominator are the same, that means that it is equal to one whole. Good job. All right, so what they want us to do is they want us to take this 50 hundredths. They put it here. And then they want us to take another number out of here. They want us to add those together to equal 100 hundredths. Well, we know it's out of 100, so 50 plus what equals 100? If you said 50, you're correct. 50 hundredths plus 50 hundredths equals 100 hundredths, which we know equals one whole. I have a feeling that's where we're going right now. Nice job. Okay, so if I take this 50 hundredths, and then I take 50 out of this 64, what am I left with? How many hundredths? Try and answer this on your own and then check your work against mine. Well, let's do a little subtraction. 64 minus 14. Or not 14, I'm sorry. And I think I gave the answer away there. Let's see. All right, my friends, we're back on track here. So we're actually doing 64. We're going to pull out 50 hundredths. You can see this number bond. So we're going to subtract out 50 hundredths, and that'll tell us what the other piece of that number bond is. 4 minus 0 is 4. 6 minus 5 is 1. So we're left with 14 hundredths here. So we're just decomposing. We're taking our addition problem, and we're just pulling it apart so that we can easily reassemble it with a whole number. Okay, so the 50 here and the 50 hundredths here, we need to add together. That's 100 hundredths. Remember, 100 hundredths is equal to what? 100 hundredths is equal to 1 whole. Good. And then what are we left with? Well, it looks like we're left with 14 hundredths. Nice job. All right. And when we add this together, now we already did this, right? We have 1 and 14 hundredths. Let's check our place value chart. 1 and 14 hundredths. 1.14. Let's see if it's correct. 1 and 14 hundredths. I had it right there. Did we get it right? Great job. Nice work, my friends. So they used fractions. I like that idea a lot. I think it's really good for understanding the math, but the standard algorithm is also a really helpful tool because it allows you to get to your answer just a little bit faster, which I think might help you guys a lot. All right, I'll see you in a second.
First, I converted the decimal numbers to fractions. 5/10 plus 64 hundredths. 5/10 is equal to 50 hundredths. I decomposed 64 hundredths into 50 hundredths and 14 hundredths. So I can do 50 hundredths plus 50 hundredths to make 1 whole. I added the remaining 14 hundredths to get 1 and 14 hundredths. I love that make one strategy.
All right, we have a new problem here. We're solving this in our notes. Make sure you're on your scrap paper or you're in your math notebook. We're going to solve 30 hundredths plus 5/10. We're going to express our answer in decimal form. First, convert each decimal to a fraction. We're not going to do this first. This is going to be what we do second. What I want everyone to do is I want you to create the standard algorithm by using your place values. So we have 30 hundredths and 5/10. 30 hundredths plus 5/10. Let's plug in our 30 hundredths first. We have 0 ones, 3/10, and 0 hundredths. And then we're going to plug in our second term, our 5/10. 0 ones, 5/10, and then I'm going to put a place value here. I'm going to put a placeholder here. Okay. Now everything's lined up. Ones, tenths, hundredths. I can add these together. Let's do it. We have 0 plus 0, 0 hundredths. 3 plus 5, that's 8/10, and 0 plus 0, that's 0 ones. 80 can't be our answer. It's not reasonable. Drop that decimal down. We get 80. We get 80 hundredths. Okay. So 0.80. I can write that without the 0 on the back too, right? It's the same number. 80 hundredths is the same as 8/10. They can be rewritten both ways. Both are correct. Check, check. Nice work. All right, let's go back to our Zearn lesson. So we know our answer is going to be 8/10 or 80 hundredths. I want you to write that down in your notebook or on your scrap paper. I have it written right here. I completed my number sentence. 8/10 plus 5/10 equals, or 30/10 plus 5/10 equals 8/10. All right. And if you have trouble reading on mine, you can read it right off the screen right here. All right, let's see if we're correct. We're going to do it their way now. We're going to start by rewriting their decimals as fractions. So notice they wrote 30 hundredths as a fraction here, and they wrote 5/10 as a fraction here. All right. You can go ahead and write that down now, my friends. Now they want us to be able to add these together. I think that the easiest way to add these together is to change our denominators to make sure they're the same. Let's change our tenths to hundredths. We'll multiply that by 10 over 10. And our new problem is 30 hundredths plus 50 hundredths. My friends, I want you to solve this on your scrap paper or notebook and then tell me what you get. While you solve it, I'll also solve it. All right, my friends, I got 80 hundredths. They want us to write this as a decimal number. So 80 hundredths, that's 0.80. And I think that was our answer from before. 8 tenths or 80 hundredths. Nice job, my friends.
Sophie, how do you solve this one?
First, I converted each decimal number to a fraction. 30 hundredths plus 5 tenths. Then I converted 5 tenths to 50 hundredths and added that to 30 hundredths to get 80 hundredths. Then I converted 80 hundredths back to a decimal.
Great. Lucas, how about you? Before adding, I converted 30 hundredths to tenths by dividing the numerator and denominator by 10. That's 3 tenths. 3 tenths plus 5 tenths equals 8 tenths. 8 tenths is equivalent to 80 hundredths. So Sophie and I got the same answer. Nice. One correct answer written in 2 equivalent forms.
Notice what they did there. So they used all fractions. We used a different format. We used a third, and in my opinion, a much faster format. We used our standard algorithm plus, that's a 0, plus 0.5, and we added it together. Remember, placeholder, so I have all my places organized. 0, 8, 0. I drop that decimal right where it needs to be. Okay, so all of these equal each other. Very nice job. They are the exact same answer. Let's continue. Here's our work.
Let's keep adding decimal numbers. Here's another one for you.
All right, y'all, once again, I want you to do the standard algorithm before you do any of this. Let's get the right answer and then try it their way. So let's use the standard algorithm first. We want to stack these by place value. You can pause the video now. Answer the question, when you add these two together, 6.8 plus 5.7, what is your sum? What is your answer? Send that to me in Google Classrooms and then come back to check your work. All right, my friends, you are back. Let's go over this together. I'm going to start by writing my first number, 6 and 8 tenths, plus 5 and 7 tenths. If you have not done this yet, make sure you're following along with me. Let's add up our places, starting with our smallest, our tenths place. I have 8 tenths plus 7 tenths. That's 15 tenths. Drop my 5, carry my 1. Let's do our next place. 6 plus 5 is 11, plus 1 is 12. 12 ones, or wholes. I drop my 12 because there's nowhere to carry that next number. And that's my answer, right? 125? Nope. For my friends that caught on, make sure you drop that decimal. And I think if I drop it down, it'll actually go right here. So my answer is 12 and 5 tenths, or 12.5. Congrats to all my friends that were able to solve it using the standard algorithm. Nice work. All right, let's go and see how Zearn does it, which I think is also a really good method using fractions. So we're going to start by rewriting these two numbers in fraction form. Start with 6 and 8 tenths, 6 wholes and 8 tenths, plus 5 and 7 tenths, 5 wholes and 7 tenths. All right, let's add these together. How would you solve this problem if you had to do it as a fraction? I want you to solve this on your own and tell me how you did it in Google Classroom. I can't wait to read your responses. I'll see y'all in a second. All right, my friends, nice work on that. Let's go ahead and see how our friends on Zearn solve this
6 and
problem.
8/10 plus 5 and 7/10. When we add mixed numbers, we can add the whole numbers together and then the fractions. We can add ones to ones and then tenths to tenths because they have the same denominator.
Yes. Try it out.
All right, y'all. So what they did here, it looks a little confusing, but check it out. They color coded it here. So they rewrote the addition expression to add like units. So they added their ones together. They're 6 plus 5. So let's put a 5 right next to 6. Okay. And then they added 8/10 plus 7/10. They added their whole numbers and then they added their fractions. 7/10. And they used parentheses to show how they added those individual units separately. Okay. Nice work. All right, y'all. We have 6 plus 5, that's 11 wholes. And we have 8 plus 7, that's 15/10. Nice work. All right, y'all. So what they want us to do here is we can take our 15/10 and I can decompose that. I'm going to do a number bond right here. All right, so 10/10 and 5/10. I can break that down into two separate fractions because I know 10 plus 5 is 15/10. This 10/10 is another whole. So that's 1, and then we have 5/10. So let's add our pieces together. We have 11 plus 1 whole. That's 12. And then I have 5/10 as my fraction. Let's see if that's correct. Nice job. Okay, they're going to do that for us here. So what they did was they take the 15/10, they pull out 1 whole. We're left with 5/10. Let's press enter. Nice job. All right, and then we already did this, but they added their pieces. So they're 11. They're 1 whole that they pulled out of 15, and then they have their 5/10 on the end. Everyone, 11 plus 1 is 12. Nice job, and we're left with 5/10. Good work. All right, y'all. So when we add these together, we have 6 and 8/10, 6.8. Remember, 8/10 is your first decimal place. Here, 5 and 7/10. And our answer is 12.5. 12.5. Enter. Nice job.
I added ones to ones first, then tenths to tenths. 6 plus 5 is
Y'all, see you in a second, okay?
11. And 8/10.
All right, my friends, we have another problem here. We're going to rewrite 5 and 6/10 plus 4 and 53/100 as the sum of two mixed numbers. Before we do this, I want you to do it in the standard algorithm. Try it on your own and then tell me the answer in Google Classroom. I want you to send me a private message. You can pause now. I'll see you in a second. All right, nice work, my friends. Let's line this up. We have 5 and 6/10 plus 4 and 53/100. I have my ones lined up. I have my tenths lined up. My decimals are lined up. And I might put a 0 here as my placeholder in the top value. Now let's add it together. Our hundredths, 0 plus 3 is 3/100. 6 plus 5 is 11. Drop my 1, carry 1 to my next largest place. 5 plus 4 is 9, plus 1 is 10. All right. My answer, 1,013. Nope, because it's not reasonable. Nice work. I have to make sure I drop this decimal down in the right place. It's going to fall right there. Okay, so I have my hundredths, and my tenths. Our answer should be 10 and 13 hundredths. 10 and 13 hundredths. I'm writing it in my notebook. You guys should already have it because you solved it, but let's see if we're correct based on what our friends on Zearn do. Okay, so they started by converting. So they didn't use the standard algorithm. They're going to use addition with fractions. They turned their 5 and 6/10 into a fraction, and they turned 4 and 53 hundredths into a fraction. And then they're going to rewrite 5 and 6/10 as hundredths. So we should be familiar with this. If it's tenths, you can just multiply the top and the bottom by 10, so 60 hundredths, to find that equivalent fraction. And now we can add because we have like fractions. 4 and 53 hundredths. Very good. 5 and 60 hundredths plus 4 and 53 hundredths. Just like this. Make sure you're following along in your notes. Let's find the sum. Okay, so what I'm going to do, I'm going to start by adding my whole numbers. 5 plus 4. Okay. And then I'm going to add my fractions over here. We'll put a little addition symbol because we're going to eventually add those together. 60 hundredths plus 53 hundredths. 53 hundredths. Now, I'm just going to go ahead and add them. 5 plus 4 is 9. Let's do 60 plus 53. We'll clean this up a little bit. 60 plus 53. That's 3 and 11. That's 113. So 9 plus 113 hundredths. Okay, I could just stick these together, but then I would have an improper fraction. So I want to look at this 9. I want to look at this 113 hundredths, and I actually want to do a number bond. So I want to do 100 hundredths. So if I pull 100 out of, if I subtract 100 out of 113, I'm left with 13 hundredths. And this right here, this 100 hundredths, that's another whole, isn't it? This is equal to 1 whole. So we have 9 wholes. We have 9 plus 1 plus 13 hundredths. 9 plus 1 is 10. 9 plus 1 is 10. And then I have my 13 hundredths here. So I'm going to scoot that right over and put it on the end. 10 and 13 hundredths. That's my final answer. But as a decimal, I know I can rewrite that as 10 and 13 hundredths. All right. These are our answers. This is our decimal form. This is our fraction form. And this is our work. Let's see how our friends on Zearn do it. They might do it a little bit of a different way. As long as you can find your whole number and your fraction and then pull out any extra whole numbers, you'll get to the correct answer. All right. Notice what they did. Same thing. They pulled out a 100 hundredths, turned it into a 1 whole. They have their 13 hundredths here. They added their 3 pieces together. 9, 1, 13 hundredths. And they got 10 and 13 hundredths right there. Right? In decimal form, we already did that. Let's take a look at how they do it.
Sophie?
First, I wrote out 5 and 6/10 plus 4 and 53 hundredths as fractions, and made like units by converting 5 and 6/10 to 5 and 60 hundredths. Then I added the whole numbers, 4 and 5, to get 9, and the hundredths to get 113 hundredths. 113 hundredths is greater than 1 whole, so I decomposed it to take out 1, or 100 hundredths. That left 13 hundredths remaining. 9 plus 1 is 10, plus 13 hundredths is 10 and 13 hundredths.
That looks great. Let's see how we could solve another way using a make one strategy.
All right, my friends, we checked our work there. We're good. So here they wanted us to pull out. I don't love this strategy. I'm going to answer this for you guys. They pulled out 40 hundredths. That equals 1 whole. If they pull out 40 hundredths from this 53 hundredths, they're left with 13 hundredths. Okay. 5 plus 4 plus, they made another whole here. 60 plus 40 hundredths is 1 whole. And then they have their 13 hundredths on the end. All right, make sure you're adding your whole numbers together. 5 plus 4 plus 1, that should equal 10. And then we're left with our decimal, or our fraction here, 13 hundredths. Nice job. All right, and 10 and 13 hundredths. Remember your place value chart for that, 10 and 13 hundredths. All right, 10 and 13 hundredths, 10.13. Nice job.
We can decompose 53 hundredths to make 1 with 60 hundredths. It takes 40 more hundredths to make 1 whole. So I broke 53 hundredths into 40 hundredths and 13 hundredths. That makes 5 plus 4 plus 1, plus 13 hundredths more. 10 and 13 hundredths. Love it. Today we used a lot of strategies to add decimal fractions. To keep practicing, head to the Tower of Power.
All right, my friends. So let's jump right into our Tower of Power. We're on lesson 13. Here we go. Okay, before we do anything for the Tower of Power, I want you to find the answer, and then I want you to do it Zearn's way, the fractional way. Start with your standard algorithm, 0.3 plus 0.25. Make sure your places are lined up. We'll put a 0 there for a placeholder. 0 plus 5 hundredths, that's 5. 3 plus 2 tenths, that's 5. 0. Look how fast that was with the standard algorithm. Check, 55 hundredths. I could even write it like this, 55 hundredths. Both work. They're both correct. Now we'll do it their way. Okay, we have 3 tenths. And we have 25 hundredths. 3 tenths, 25 hundredths. Nice job. All right, the 3 tenths, I need to convert that to hundredths before I can add it as a fraction. So how many hundredths is that worth? Go ahead and answer it now. How many hundredths? If you said 30, you are correct. All right, and then we're going to go ahead and add those together. 30 hundredths plus 25 hundredths. 30 plus 25. How many hundredths does that give me? If you said 55, you are correct. Nice job. And last but not least, we need to convert it into a decimal, 55 hundredths. There are no whole numbers, so 0 point what? If you said 0.55, 55 hundredths, you are correct. Nice work. We're climbing, my friends. Nice job. All right, again, let's get the answer first, and then we'll solve it on Zearn. So do your standard algorithm in your notebook or on your notepad. All right, I would try it out on your own and then come back and watch this video, finish this video. So I pause the video now. All right, I hope you have the answer. Let's check it. 5 and 4 tenths. Let's line it up. 7 and 8 tenths. Our ones are lined up. Our tenths are lined up. 8 plus 4 is 12. Drop my 2, carry my 1. 1 plus 5 plus 7, that's 13. And we'll make sure that our decimal is in line. Our final answer should be 13 and 2 tenths. Another way to write it would be 13 and 2 tenths, just like this. They are both correct. One's in decimal form, one's in fraction form. All right, let's do it their way. For fraction form, we're going to start with 5 and 4 tenths, 5 wholes, and 4 tenths. Over here, we have 7 wholes and 8 tenths. Nice work. Start by adding your whole numbers together. 5 plus 7 is what? If you said 12, you're correct. And 4 plus 8 is what? If you said 12 tenths, you're correct. Now notice, this is an improper fraction. Our numerator is greater, so they might say it's wrong. We might have to go back, but let's check. Great job. So I think they're going to have us do it in the next slide. Yeah, here it is. So they pulled 10 tenths and made a whole, okay? And we're left with 2 tenths here. So our final answer is 12 plus 1 plus 2 tenths. That's 13 and 2 tenths. Nice job. How do we write 13 and 2 tenths as a decimal? Go ahead and plug it in. If you said 13.2, you are correct. Nice job. All right, my friends. I'm going to have you do the final Tower of Power problem on your own. I want you to try your best on this. I'm going to give you a little hint about the standard algorithm, okay? 6.9 plus 7 wholes, 0.4 tenths. All right, y'all. So for this problem, I want you guys to try it using your standard algorithm first, right here. Okay. And then once you solve it with your standard algorithm, you'll have an answer. Notice what I did. I lined my ones, my tenths, and then for hundredths, there's hundredths here, but not in our first number. So I just put a 0 on the back of 9 in our hundredths place so that everything stays organized. Make sure decimal points in your answer, add it together. That's the preferred way to solve this. I think that'll be really good for you guys, the standard algorithm, okay? But I also want you to practice it the Zearn way. So I want you to do it the fractional way. Start by adding your whole numbers and then add your fractions up, okay? You might have to change some of the fractions around. You guys will do fine. I'll see you in a second. I'll see you over at the at our exit ticket where I'll give you some hints and some tricks and some tips on how to do that. All right, y'all. See you in a little bit. All right, my friends, we are in Edge Elastic right now. We're on your exit tickets. I hope everything went all right on your Zearn lesson. Again, you just finished up Zearn lesson 13. This is Friday, May 1st, exit ticket, module 6, lesson 13. Let's look at question 1. Remember, like always, watch this whole YouTube video straight through and then also complete that Zearn lesson before starting this exit ticket. Question number 1, solve the following addition problem. State your answer as a fraction and as a decimal. You're going to solve it 2 ways. A, you're going to do the addition problem first. So they already did some of it for you. We have 2 and 1/10 plus 3 tenths. They already changed 2 and 1/10 to 2 and 10 hundredths. So now we can just go ahead and we can add our fractions together. What is 10 hundredths plus 3 hundredths? All right, remember, when we're adding fractions, you only add those numerators together, and then you can put your whole number right in front. And then once you have your fraction answer here, once you add these together, change that into a decimal. All right, if you want to use the standard algorithm for this, you can. We're going to go over that in a second. So you're going to solve this two different ways. Same problem. I need the decimal answer and I need the fractional answer. All right, question number 2. A, change the fractions in the addition problem below into decimal form. So what I need you to do is this. There are 2 values being added together, 3 and 24/100ths. I need you to turn that into a decimal and put it here. And then 7/10ths. I need you to turn that into a decimal and put it here. So you should have the same addition problem, but now you should have your 2 fractions as decimals, all right? That's part A. Part B, you are going to solve this new addition problem right here, the one that you create. You're going to solve that by putting your decimals in the standard algorithm, all right? That's vertical addition. It's what we talked about a lot in earlier in the YouTube video. This is your hint. Make sure your 1s, your 10ths, and your 100ths places are lined up. Make sure your places are lined up. I'll give you an example in the next problem, okay? And then you're just going to put your answer right here. It needs to be in decimal form when you add those together. All right, our next problem. 3, solve the following addition problems by using the standard algorithm. Write your answer in decimal form. All the standard algorithm is when we add our numbers in vertical form. So like 38 plus 47. Standard algorithm. But we're using decimals now. So you have to make sure all your places are lined up and your decimals are lined up. So I'm going to give you one example. Let's do A. So I gave you this place value chart. You might want to create your own or look for one online, all right? But you have 6.4, so that's 6 1s and 4/10. 6.4 plus 5.3. My 1s are lined up, my 10ths are lined up, and my decimals are lined up. Now I can add. 4 plus 3 is 7. 6 plus 5 is 11. Carry 1 to the next place. Drop your decimal down. My answer is 11.7. That's a freebie for my friends. 11.7. All right, guys. Make sure you're doing the math on your own. Just don't just write the answer, okay? All right, that was A. For B, this one's a little different. Make sure you plug it in. You have 2 1s and 1/10. 2.1. Here you have 5 1s, 9/10, and 4/100. Notice how I wrote it. If you do it on your paper, it might look like this. 2.1, 5.94. My decimals are lined up. My 1s are lined up. My 10ths are lined up. And I don't have 100ths on top, so I can put a 0 there. All right? When I add it together, well, I'll let you add that together. Just make sure your decimal's in the right place in your answer, okay? Now, I'll tell you what you don't want. You don't want this. This is a big mistake. 2.1 and 5.94. All right? It looks like it should be right, but this is wrong. X. That's a big no-no. I'll put 3 X's, okay? Because you can see the places aren't lined up. My 1s here aren't lined up with the 1s up top. My 10ths aren't lined up with this 10th. And I know because my decimals are not stacked. They are not on top of each other. My places are all over the place. This is correct. Make sure your numbers and places are lined up, okay? You're going to do all 4 of those problems. And let's go to our last one. I'll read it out loud. Mr. Prada wants to add together 3.7 and 0.04. He uses the standard algorithm to solve and has one of his all-star math students check his work. Jasmine says the answer is incorrect. Oh no, answer's incorrect. What did Mr. Prada do wrong when he set up his problem? Explain how Mr. Prada can fix his standard algorithm and then find the correct answer. I need you to answer this in 2 complete sentences. Pay very close attention to how I did the problem. This is my work, and it is wrong. Check it out. What's wrong with this problem? Think about the last example, and how can you fix it? I need you to tell me how to fix it and what the correct answer is. All right, my friends, great job. I'm proud of you, and I'll talk to you all soon. Reach out if you need help. Peace.